We're working on this mine block functionality, and we need a hash for our new block, or to be precise, for the previous block, but we need to add this hash to the new block then. Now, of course, later we'll have a nicer way of calculating this hash, but right now what I want to do is I want to convert this dictionary into one string. And my idea is that all these values here, so all the values in the dictionary itself, so previous hash and index, as well as all the values of my transactions are concatenated as one long string, maybe separated by dashes, maybe not. And how could we do that? Well, let's have a look at something we already saw before, a for loop. Let's loop through all our keys in last block. Because, and that's important to memorize, if you're using a for loop on a dictionary, it will not loop through the values, it will instead loop through the keys. Though we will also see a way to change this, but that is the default. And that's fine here. So we can still get the value by inside of the loop using our block and of course accessing a certain key. And that's another new piece of information. For a dictionary, you access a value just as for a normal list like the blockchain, you use 0, 1 and so on. For a dictionary like last block, you use the names of the keys with quotation marks, just as you define them here. So we could access previous hash to get the previous hash of this last block. Now we have a loop, so we loop through all the keys, so we can dynamically access the key, and if we access the dictionary on a certain key, we get back the value for that key. So with that value, we can of course add it to some string which we want to concatenate. So I'll add a new value or a new variable hash, and that will be an empty string, and then, or hash is a reserved word actually, so let's use hashed block maybe. And then inside of the for loop, I'll use hashed block 2, and I will take my old hashed block and then add value here. Now I'll use the string function to ensure that it's converted to a string. Now if we do that, let's print our hashed block for now to see what we're getting. For that, I'll also go down to our while loop so that we can execute this. And I'll add a new option here. 2 will now be mine a new block, and output will be free. Therefore, I'll change this else if case to free, where we output the blockchain elements, and I'll add a new else if case where we check if user choice is equal to 2. And if it is, then I want to call mine block. So I'll call mine block here, and with that we can execute that file and see what we're getting as a hashed block for now. So let's execute our blockchain.py file. And I was in dictionary fever. We should of course add the colon in the string. We're not creating a dictionary here, excuse that. So let's restart that after fixing that print statement. And now I'll add a new transaction value. Manual receives, let's say, 10 coins. And with that one transaction added, let's mine a new block. And I get an error. List index out of range. Now, what's the issue here? It's referring to blockchain -1. So this is not working. And the reason for that is I created this nice Genesis block, but I haven't added it to the blockchain. So let's add it as an initial value. Sorry about that. With that now, we should be able to re-execute our code, enter a new transaction value, manual 10 coins. And now if you mine a new block, we still get an error, but it's a different error now. Verified chain fails. Now that also makes sense because if we go down to our while loop, we do call mine block here, but we always try to verify the chain at the end. Let's comment this out for now because it can't succeed. We changed so much, the old way of validating it won't work anymore. So with that, let's start it one more time and let's now again add a transaction to manual, mine a new block, and now let's see what we got. This is the output we're getting from our print statement in mine block. here, the hashed block. It's a string which includes nothing as the previous hash because the Genesis block has an empty string here. Then 0 for the index, and then our list is also just printed like that. Now that's our hash being calculated here, the hashed block. Now let's see how that hash would look like if we mine another new block. Then you see it includes the data for our previous block, which has this dummy hash of XYZ, which has 1 for the index, and then the transaction list printed to a string 2. So that's something Python can do. It can easily convert this list and dictionary to a string and give it to us like that. So now we got that hash being calculated. So now we can store that hashed block as a previous hash for every new block we generate. With that, we made a huge step forward. Let me quit that process down there. One thing I want to change, 4 keys, I'll name it 4key because it's really just 1 key in each iteration. It's just a minor thing though. But with that, we got a nice basic hashing algorithm. However, I want to show you an alternative to that.